What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, and specifically the 3D fighter, we're going to be going over 3D hitboxes part 2. So we have our fighting game tutorial series, and then we have this mini series, which is converting the 2 and 2.5D fighter to 3D. Everything that we've done in the fighter works with this. This is just an addition that I'm adding to my fighting game. It's not even a separate project anymore. At this point, I have combined them because I have a solid path forward on everything. So as we come into the game here, we have our fighter as you would normally see it. And then a few episodes ago, we added a cheat to swap from 2D and 2.5D to 3D and vice versa. So we can cheat enable 3D mode equals true. And what this does is allow us to rotate around our character and move in 3D space. It does a few other things, like change the way we actually can move when we're looking at our opponent. Like how we can go left and right and still look at them, instead of just moving back and forth and the characters are flipping. And in the previous episode of this series, we actually added 3D hitboxes, which are our complex hitboxes, if you remember from the series. So if I go into practice mode, you can see that we have our 2D hitboxes here with all our practice mode data, and then I can go and run my 3D command sheet, and you see that all the hurtboxes change to our 3D hurtboxes. So specifically what we're going to be doing in today's episode is making 3D hitboxes from our attacks so that we can actually damage or collide with these 3D hurtboxes. Technically the 2D ones can collide with the 3D hurtboxes as long as they're in the right space. However, we get into some weird scenarios because if we try and use our attack here, like at this angle, you'll notice that we aren't really where we need to be for this. Our attack is specifically for 2D and 2.5D. And we need to modify this so it has a 3D transform as well. So instead of going to the right when I'm using this attack, it should still be facing the way my character is facing. If you want to get caught up in the entire series before you check this out, so you can see how we've done things like our 2D fighter hitboxes and our different types of hurt boxes, our input stack in different modes, I'll link you to the entire playlist right here in the top right corner so you can check that out. Alternatively, if you don't care about that and you just care about the 3D hurt boxes and 3D hitboxes for the 3D fighter, I recommend you watch the previous episode of the 3D fighter with the hitboxes, which I'll link you to right here. If you watch that, you'll be in a good state to follow along with this episode. So with that out of the way, we can go ahead and get started. Now, initially when I was going over this hitbox actor and trying to figure out what I wanted to change to 3D, I had thought about adding a different variable in here, like another transform called hitbox data 3D or 3D hitbox data, so that we could read in a field from the data table and then put it in the proper spot. However, I don't think this is relevant or necessary because our 3D hitboxes should really be in the same spot that our 2D hitboxes are, except they will be relative to the character that is using the attack, not just on location, but rotation as well. So if we're rotated facing the character, I don't want it to appear to my right, I want it to appear in front of me like I was mentioning earlier. But now there's also the depth element of the location for the hitbox. But the F hitbox data here is this struct, and this has a hitbox transform, which has a location, rotation, and scale. The location, rotation, and scale have all relevant axes, so we don't need a separate transform for our 3D hitboxes. We just have to fill out the fields we didn't fill out for our 2D and 2.5D hitboxes if we expect to change the 3D hitboxes on that new axis. So hopefully that makes sense, but if it doesn't, it should when we get into an example here. So I don't need to change anything in my hitboxactor.h or my hitboxactor code at all right now. I want to do this all in Blueprint first, since the hitbox data is in Blueprint, and then like I did with our camera, I will convert it all to code afterward. So anyone following the series who's using a Blueprint only project can still follow along with this logic. Then whoever's following the fighting game series as a whole can take the logic that we implement in today's episode and convert it to C++ for a performance gain. The main thing we need to do today is edit our animBP function. So we need to go to the animation blueprint for all of our characters really, but let's just do it for one character, and I'm going to go to my mutant animBP, root motion. In the animation blueprint, we have these functions for creating different types of hitboxes, such as proximity, active, projectile, and throw. I've added a new one called create hitbox 3D for today's episode. No, I don't believe we need a separate function for this. We can pretty easily convert between the regular version of the hitbox and the 3D version just by checking our isFighter3D boolean that we have. That's what determines if we're in 3D mode or not. But because the hitbox logic is pretty complex, I wanted to separate it so that we can just make sure we get the 3D hitboxes working. And then when we do, we'll have another episode, the episode after this, on this topic, to combine it with the rest of our hitbox logic. Now let's go to where our hitboxes are. So I have this section of my AnimBP where I am applying the properties from my hitbox data table. So I have a mutant hitbox data, and then I'm grabbing the proper row name at the appropriate anim_notify. This anim_notify is when the hitbox should be spawned. So it's finding the proper data, getting the data from the data table, and then creating a hitbox with that data. This goes for all of my hitboxes. Let's make sure we have this hitbox data table. So if we go to blueprints for me, library blueprints, and I go to my mutant hitbox data, here is my data table with all my hitbox data. And you can see in here we have hitbox transform. And take a look at the location field of hitbox transform for all of these. You noticing that the X value of the location is never touched? That's because we don't use that axis in our 2D and 2.5D fighter. For the 3D fighter, we very well may use it. You absolutely don't have to, but we may want to. Say we have a jab that doesn't appear directly in front of our character, but it's going to go a little bit to the right of our character. We would utilize the X location in the hitbox transform. So this is what I was saying earlier. We don't need a different variable for our 3D hitboxes. We just need to use what we already have. And the same goes for rotation and scale. You'll notice we also don't do anything for our rotation on any of these. It just wasn't really necessary. You could. The series supports it. In this case, though, with our 3D hitboxes, I could see more of a use for it. Just be aware of this. We'll come back and show an example with, say, light attack hitbox 2 here, and I'll make it work for 3D. Now, when we're inside of our animation blueprint, I'm going to make a new function, plus function, and I called it create hitbox 3D. Now, again, I made this function just to separate it from the other hitbox logic so that we can get it working first. And once we get it working, honestly, it's a pretty easy conversion to make it work with our existing hitbox functions. But I think it's easier to explain it this way because there is a lot of logic in here. Right now, we are going to be doing some duplicate logic in this function and say create active hitbox. So I have create hitbox 3D. And you can see I've already filled out the logic for this, but I'm going to go over it with you every step of the way. So create hitbox 3D takes in a hitbox data struct. Hitbox data is our C++ structure that I was showing you earlier, where it had the transform, the type, basically everything that's in our data table. So it's just taking in an entire struct instead of taking in the individual variables like something such as create active hitbox. Takes in every parameter on its own, which is technically fine. It doesn't really hurt anything to do this. But the node can be quite tall at this point, and we have to pass in all these things manually, whereas if we just pass in the structure, everything is contained within here. So it's not required you do that, but I think it is a nice touch. Otherwise, you can go ahead and just make sure you add every variable that create active hitbox has as a input parameter here. But for me, I just have the structure, and I've called it hitbox data. And at this point, we're going to follow pretty standard procedure for creating a hitbox. We're going to spawn actor, hitbox actor BP. So this is our blueprint hitbox. It does have some logic for collisions and projectile behavior, but most importantly, at this point in the series, is that the blueprint hitbox is what has the actual mesh on it. So that's where you can see the box in practice mode and know where the hitbox is at. So to get this node, we just do spawn actor from class, and you want to pick class, and it's going to be your blueprint hitbox. For me, it's hitbox actor BP. And then from here, we're going to pass in our player transform. Player transform is a variable that we have on the animation blueprint, which basically tracks the owner of the AnimBP and takes their transform. We do this in event blueprint update animation, which is essentially the tick for our AnimBP, and you can see we are setting player transform to the owning character, or the character references transform. So simple enough, we're just making sure that we set the default spawn location to where our character is. The rest of the settings are fine, but it is important that we also set the owner of the hitbox, because if we don't set the owner, then we don't know if we can deal damage to the opponent or not. And to set the owner, you can click this little arrow here. If I am to disconnect this, you'll see that the node looks like this initially, and the owner field isn't here. So if you press down on the little arrow here, you can then pass in the owner. And for the owner, we're going to use try get pawn owner. Again, this is just the owner of the animation blueprint. You could also use your character reference variable here. Just get character reference and pass it in. This function should never be called if character reference isn't valid. Either way, this is what we need to do to spawn our hitbox actor. Simple stuff, but I just want to be thorough. For this next set of logic, we need to take the hitbox data that exists on the hitbox actor BP. So you saw when we were in code earlier that I have a variable of hitbox data here. It's just an instance of the struct. That way we have all the data about it. We need to set the members in the struct to the values that come from the data table. And the values that come from the data table are the values that are going to be passed in to create hitbox 3D here. So if we drag off of our hitbox data that's being passed into the function, we can type break hitbox data or break structure. Then you can press the down arrow to see all the variables in hitbox data. So you'll see that's what we have here. Hitbox data is going over here to this break hitbox data. And then we're dragging off of the spawn actor hitbox actor BP node and getting hitbox data, the variable. So that's these two nodes here. Now the logic here is pretty simple. Again, this is very similar to our other hitbox functions. We're going to drag off of our hitbox data variable and type set members in and then structure name, which is hitbox data. This means we just want to set variables that are in this structure. I'm going to go and check every single pin because I do want to set all of them. If you don't need all of them, then don't select the pin. You don't have to pass it in. And once you do that, you're going to get this node here. So that's what we have here. And you see that the hitbox data is going into the structure reference. And the values we're setting for each of these things are coming from the hitbox data. And again, this is the data from the data table at the correct row for the given hitbox. So we're just going to pass pretty much everything in one-to-one. Type is going to go into the type. Height is going to go into the height. Hit sound, damage, frames, all these things are going in one-to-one. So the location, rotation, and scale are the odd ones out here. Technically, you can put the scale in here, and it's not going to hurt anything. I just kind of skipped over this whole section because I knew I needed the location and the rotation from the data table. But if you have set up your scale in the data table, you can pass that in directly. The only ones that require any sort of modification are the location and rotation. Location being the biggest one, because the location that we put in the data table is really an offset, right? If I say my hitbox transform for my location is -120, that is going to be relative to my character. I'm not positioning the hitbox at position -100 on the Y and 20 on the Z. If I did that, it would be nowhere near where my characters were. Especially as I'm moving around the stage, this would be a static value. It has to be in relation to our characters. And we already have that logic for our 2D fighter, because all we have to do is grab the location of them and then either add it or subtract it based on what side they're on. If I'm facing right and I want to perform this attack, then I want to subtract 100 like in this example to get it farther to the right. But if I'm facing left, then I want to add 100 to get it farther to the left. In the 3D environment, we have to take into account the rotation of the character. And so these positions are still relevant and they will work because they're just offsets. But in our logic, when we're figuring out the actual location that this hitbox is going to spawn, we have to take the hitbox transform location, which is really the hitbox offset, and we want to add it to the player transform location. So remember, we have this player transform that we just used earlier to spawn the hitbox. To figure out where to move this hitbox based on the data table value, we need to get the location of this character. What I did for this is just split my player transform struct pin. So right click on the pin and then just split struct pin, and you'll get the three things that make up a transform, which are the location, rotation, and scale. So that's how we get this node here. And for now, let's not care about scale. Scale could be a factor. Like if you want to scale your characters up, the hitbox should scale with it. That way, if they're like 10 times taller, the hitbox still appears at the right spot. But let's ignore that for now because we don't have that sort of feature in our game. we have the location and rotation. So all we want to do for the location part is just add the hitbox transform location from the data table to the player's location. This is the same process that we're doing in create active hitbox, for example. We have more nodes in this function, but really we're taking the transform of the character, breaking it into the XYZ of the location. Then I'm adding either the offset location coming in from the transform location, XYZ, or I'm adding that value multiplied by -1. So I'm basically adding or subtracting that offset. What we're doing here in Create Hitbox 3D is no different. We're just adding the offset. But you see I'm using player transform rotation here, and I'm getting the forward vector. With a vector, it points a given direction, and with a rotation, we can figure out what direction that is. So you take the player transform rotation, pass it in as the in rotation, and it will give you a vector in the direction the character is facing. This is exactly what we need to offset our hitbox correctly. At least conceptually, because this matches what the 2D version, the Create Active Hitbox version, was. But for 3D, what we need to do is take the corresponding axis, which in our case is our y-axis, and we need to use this when spawning the hitbox so that we spawn it in the correct spot. So you can see I've updated the logic here, where I'm dragging off of my hitbox transform location and I'm breaking it using break vector. Then I'm dragging the y-axis into a multiply, and I'm using the get forward vector as the vector that we're multiplying the y-axis by. So basically what we're doing here is getting the direction the character is facing, multiplying it by the offset, then we're going to add that to the player transform for the final result of the hitbox transform. Now technically there are other cases we need to consider, and so if you do this, it is going to be offset to your left or your right, but it will be consistent. So what I recommend for today's episode is just to make sure it's consistent. As you rotate around your character, you should spawn a 3D hitbox, but it won't be directly in front of the character. It will be to the left of them or to the right of them. In the next episode, that's when I said we would be going over actually moving where our hitbox is, and this is when we will address this. It'll be super easy to address, and if you want to see what it'll look like when we actually get this correct, instead of passing the y-axis in, you can pass in a value like 0 or the x-axis. If you do that, the hitbox will be in the center of the character. Regardless though, we'll be updating it in the next episode. But this is already going to be a pretty long episode, so we'll cover all of it in there. So I'm going to intentionally leave these few nodes down below here and not clean it up, because this is what we're going to be addressing in the next episode, and we'll clean it up once the logic is finalized. I also recommend passing in the player transforms rotation for the hitbox rotation in our set members and hitbox data struct here. I mentioned this a little bit earlier, but this will just make sure that it's rotating with the character, but I think by default it should do this. After this, we want to use the struct that we just set the data for to do a few additional operations. So we take the struct out of the set members and hitbox data and we break it into hitbox data. This time I only have my transform and my should attach because that's all I need, so I can disconnect everything but those. And it will look something like this, and then I can split the struct pin just like we did for the forward vector section, and you see I get what I have right here, and I'm going to set the actor rotation and scale after the fact now. So to do this, I want my spawn actor hitbox actor BP reference. This return value is this reroute node, and so if I drag off of it here, set actor rotation, I can then pass in my rotation from my broken hitbox data, and I don't need to have teleport physics on. From there, I have another node, set actor scale 3D. So we're just setting the scale of the hitbox. That's going to come from the hitbox transform scale here. And then I also am going to determine if I should attach this hitbox to the character or not. So in our game, we have the ability to spawn a hitbox, attach it to a point on our character. So for example, I have a spinning kick that I can do, and it's just sticking in place as I move with it. If you're supporting this logic, then you might as well follow along here. So we have should attach, and it's going into a branch. So should attach, branch. And if it should attach, I am using the hitbox actor. This is the same reroute node as before. And I'm calling attach actor to actor. We want this one here under transformation. And the hitbox is the target. The parent actor is going to be our character reference. because we're attaching it to our character. And you could supply it with a socket name if you wanted. We didn't really do enough with this, so I just needed it in the center of my character to follow me around. But obviously set your settings here as you want them. So I kept everything default. That's how I have these nodes here. But if we don't attach, we just skip this. Don't do this logic. And if we do attach, we still go onto this logic, so the paths meet up here. And we actually drag off of our hitbox actor BP reroute node one more time. We're going to call spawn hitbox this time. This is what triggers the logic in the hitbox actor BP to start checking for collisions, determine if collisions between certain characters is valid, or if they're on our team, or if they're us who spawn the hitbox and we can't harm ourselves, that sort of thing. And then at this point, this is just to support how our animation blueprint is set up. Since I was spawning an active hitbox here, I was destroying any proximity hitboxes that came before it, and then clearing the proximity hitbox array. This is just so we don't have any hitboxes that are still active. Hitboxes now support lifetimes, so they can get destroyed after a given amount of time, so this really isn't a big deal. But again, if I go to create active hitbox, for example, we're still doing this. I don't want to mess with this logic for today's episode. It's outside the scope of it. So I'm just keeping it as is. So you can copy and paste it directly. If you'd like to know what it does though and you're not sure, basically we have an array of hitbox actor BPs, and these are our proximity hitboxes. So these aren't the ones that deal damage, these are the ones that can determine if a receiving character should block an attack or not. And I'm just looping through them. If there are any, we're going to destroy them, and then once we get through the loop, I'm just clearing the array. So we make sure that we get rid of all of our proximity hitboxes before spawning an active hitbox. This is a variable on our anim BP. And then I take my hitbox actor that was spawned in this function, and I add it to active hitboxes array. Same idea, but these are the hitboxes that we call strike hitboxes that can deal damage. Some other stuff I have in here, just related to general match flow when attacking. So whenever we spawn an active or a strike hitbox, then I like to set the attack state to attack active on the character. This determines a lot of things throughout the series, such as if they can combo, do certain actions, whatever the case may be. If you've been following the series, you'll know this. If you haven't, you probably don't need to do this. This is very specific to the fighting game series, not the hitboxes. And same with the frame count here. This is for practice mode. Whenever we perform a new strike attack, we set the first active frame, and we do that by just getting the frame count in Unreal. And there we go. So this is the create hitbox 3D function. Now that was a lot, but a lot of it was copy and paste from the create active hitbox. The biggest differences were the structure instead of individual variables, and setting up the forward vector to determine where the location should actually be in a 3D environment. Now, if we go to the event graph and go back to our hitboxes, I have some very ugly logic here that I added just for today's episode. It is pretty much going to be how this logic is, but we can improve this vastly. So I kind of just threw this together quickly. Basically, I have two different attacks that use the same hitbox here. This is what I call my rifle punch. It is a mixed mo animation. It is my light attack. When we're ready to spawn our active hitbox, I get the data table row from mutant hitbox data, and to do this, you can just type get data table row. You want the one under utilities. You're going to pass in your data table, so mutant HB data. And then you can pick the row you want. I know which one it is because it's only going to happen for light attack hitbox 2 if I'm entering it from these notifies. And this is what I was showing you before. We get the data, and then we were breaking the data and passing it into create active hitbox. Remember, we had this right up above, right here. But now it's a little bit different because in this case I want to either spawn a 3D hitbox or my active hitbox based on the type of fighter mode that it is. And to do this, to determine if it's fighter mode 2D or 3D, that is on our game instance reference. If you look at our variables in the animation blueprint, we don't have a game instance reference, so you could simply just add one, or just get the game instance here and cast it. What I did to follow some of the other things that we've set up in this animation blueprint is use our game mode reference to get the game instance reference. In my opinion, it's a little bit of overkill right now, but again, I don't want to modify the actual logic we have in our NMBP. I have a separate set of episodes They're being released alongside these episodes that clean up the animation blueprint greatly. I don't want to mess up any of that logic or make it more confusing when going over those episodes. So I'm just keeping the same methods the same way through. That way we can address them in one sweep instead of setting them up in different episodes. So I'm just using my game mode reference here and getting it and then converting it to a validated get. And if it's valid, then I'm getting my game instance reference off of the game mode reference. And then I can convert this to a validated get. And if this is also valid, I was using the game instance reference to check our isFighterMode 3D boolean, which again is what determines if we're in 2D or 2.5D or 3D. If this is false, I'm doing the same thing that we were doing before to actually spawn the active hitbox. So you see create active hitbox right here. And I've broken my hitbox data from the data table row and passed in every variable manually, just like we did in the example I gave you earlier. But if isFighterMode 3D is true, we can now use our new function, create hitbox 3D. So we just call this, and drag it in or type it in, create hitbox 3D. And then you will want to pass in your out row from the data table as the structure. And you'll be good to go. So now if it's 2D, it'll use the regular method that we know already works for our 2D hitboxes, and if it's 3D, we'll use our new method. Compile and save. So now feel free to modify your location on your X values if you want. Like I said, we will be showing examples. I'm not going to do it today because there's more that goes into that. This is what the final result should look like after today's episode. More to come in the next one. I hope you enjoyed the second episode of 3D hitboxes for the conversion of the 2 and 2.5D fighter to 3D if you're working on a 3D fighting game. If you did, please subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out to my YouTube membership, Discord members, and Patreon supporters. You guys are fantastic. Thank you for all the love and support. I am so incredibly grateful. If you ran into any problems following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description, and I would be happy to help you. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.